2 exponential minus 3 amps. You can have your current to be 2 microamps. So your M here signifies milli. Now your micron here signifies micro. Do you understand? So from here you have it as 2 exponential minus 6 amps. Now if you still go for that, you can have it as 2 nano amps. This is known as nano. Your nano could be expressed as 2 exponential minus 9 amps. You could still go further by saying it is 2 pico amps. This P here means pico, which will be given as 2 times 10 raised to the power minus 12 amps. If you still want to go further, you can have it as 2 Tesla amps, which is what? 2 exponential minus 15 amps. Like that downward. Can be having them as your what? Unit. You understand? As a minute object being attached to every of your what? Values of current. So these you must what? Practicalize and what? Know properly. Now let's proceed to another one. Still under our what? Current. Still under our what? Current. Now we're looking at current measuring instrument. Current measuring instrument. The instrument that you can actually use to what? Measure your current. Now, he said the major instrument for measuring current is what we call your ammeter. Ammeter. Ammeter is the major instrument that you use. Ammeter. That's the major instrument for measuring your what? Your electrical current. You can also have another one called milliammeter. You can see milli is just what is being brought in. Now your milli means a smaller what? This is a normal what? Value. Do you understand? This is for a smaller value. So both can be used to measure your what? Electrical current. Your ammeter or your milliammeter. Another one we have is your what? Galvanometer. Galvanometer. It can also be used to measure your what? Electrical current. So without wasting more of our time, we will still look deep into these three as regards their what. And very good. You can see from our diagram there, the actual graphical representation of what? Ammeter and your what? Your milliammeter. Let's proceed to potential difference. Let's proceed to potential difference. What is potential difference? Potential difference at any point in a circle is being defined as the work done in joules when one coulomb of electric charge moves from one point to another. Now, the other time we said when you have your charge, remember we said PD, which represents your potential difference. We said it is the work done. It is the work done by what? A current. It is work done by a current when it moves from what? From one region to what? Another. In where? In an electrical circuit. Why I'm taking my time to write it out this way is that every definition in sciences matters. Your definition must be constructive. It must have reasonable meaning. If you have written it that, okay, if I am to say to you a question now that, okay, define for me your potential difference. If you are to tell me that it is the work done by a current when it moves from one region to another, if you did not put the electrical circuit, you might as well fail that particular question. Why? Because you are not being analytic. But if maybe you put your electric circuit, it means that you are being specific that this particular occurrence of movement of current is not just anywhere, but what? In an electrical circuit. So this is a very good, perfect definition of your what? Potential difference. Now, when one current of electricity moves from one point to another, work is actually done. This is where you are going. It is the work done. It is the work that is done that will make you record your what? Your potential difference. If there is no movement of what? Electrical charge from one region to another, work will not be done. It is this movement of this electrical charge that will actually make work to be done. So when work is now being done, you now be able to obtain your potential difference. Now, what are the instruments that you can use to measure your potential difference? That instrument is what we call your voltmeter. I think I mentioned it earlier. You have your voltmeter. Your voltmeter. Your voltmeter is used to measure what? Potential difference. Now, let's go to we've spoken about the instrument. Now let's go to another particular subtopic, which is a very good one. It's a very good, interesting one in sciences. Now we're looking at another subtopic under our current electricity, which is called Ohm's law. Ohm's law. Every aspiring scientist or every aspiring engineer must always understand that when physics, chemistry, and mathematics is as far as physics, chemistry, and mathematics is concerned, you must know and get acclimatized to different laws and theorems, and they must sink into you. So let's go into Ohm's law. Who is Ohm's law, or who propounded Ohm's law? How did this work? Okay, you know about law. Law is a particular stipulated write-up that everybody must adhere to. But what is this Ohm? Where did it come from? This Ohm is the name of a scientist called George Ohm. One of our oldest scientists or physicists, let me put it that way. George Ohm. George Simon Ohm. That's his third name, George Simon Ohm. Now, this George Simon Ohm is a German. He's a German scientist. He's a German scientist, and he propounded this law in the year. George Simon Ohm is a German scientist, and he propounded the law in the year 1826. And you can see more than a decade, more than a century ago. Now, the current person, now that law which he propounded then, we are going to state it now. Listen to the analysis of that law for you to actually know that the law is very much comprehensive. The law is still very much related to even these days and day-to-day activities. Now let's look at it. The current passing through a metallic conductor. The conductor is your wire, because at every definition I'll be doing the diagrammatical representation for you to actually get the meaning of that law. If this is to be your metallic wire, I'm not going to make it straight because I'm not drawing a rod, I'm drawing a wire. Of course, you know that your metallic wire will conduct electricity. Look at it too. This, let's say this is your point A of your metallic wire, and this is your point B. Okay, let's proceed. The current passing through your metallic wire at constant temperature is directly, mathematics, current, I. Are you getting it? Is directly proportional. Proportionality, when you say directly proportional, you just put your I alpha. The current passing through a metallic conductor that is a wire, at constant temperature is directly proportional to the potential difference between the two ends. Where is the potential difference? V. That's your volt. I think we spoke about that now. If you analyze this theory very well, it said at constant temperature, meaning that let's assume that the temperature surrounding this metallic wire, let's say it's at room temperature. You know what they call room temperature? The temperature that is not too high or too low. So it's at room temperature. We are assuming that for as long as the temperature surrounding this wire is constant, it's not too high and it's not too low, this law will hold. That's the actual meaning. Meaning that if you go and practicalize, or if you go and state this law in a place where there is an instability in the temperature of that particular region, this law might not hold. That's the meaning. But at constant temperature, the current passing through a metallic conductor is directly proportional to the potential difference of the two ends. Where are the two ends? This is end 1 and this is end 2. This current is directly proportional. So if you now want to remove the constant of proportionality, your resistance will come in. So your V There is an error there. The current is directly proportional to the potential difference. Now, if you must bring out the constant of proportionality, it's going to be 1 over r dot v. Now, where your 1 over r is your what? Constant. Constant of what? Proportionality. Constant of proportionality. Meaning that if you are to write this definition properly, you now have your I equals what? V over r. What is your V? You need to get it. Your V is your what? Potential difference. Potential difference or voltage. Your R is what we call your resistance. Don't worry, we'll still talk about that properly. Now your I is what we call your current, which is what we are discussing now. So from here now, you now be able to obtain three formulas. You can have your V to give you IR. You can have your I to give you V over R. And you can have your R to give you V over I. These are the three definitions that can be obtained or that is obtainable in terms of Ohm's law. So those are the real analysis of what? Ohm's law. Wherever you are and you are being told to what? Break down Ohm's law. To use your diagram to actually explain what is meant by Ohm's law. These are what is expected. You state all the parameters equal and remember to write at constant temperature. Because if you do not put it there, it means you are assuming or you are telling the whole world or your examiner that this particular law can hold at what? Unstable temperature. But no, it is at constant temperature. So that is all about Ohm's law. Now let's go to what we call resistance. Let's go to what we call resistance. What is meant by resistance? Now if you look at it properly, you realize that if you go ahead breaking it down,